Recall that a point estimate is a statistic calculated from a sample that is used to estimate a population parameter, whether a proportion, difference of proportions, or something else. Point estimates are basically your best guess from your sample, but they are rarely perfect. So for instance, I flip a coin 100 times, it's unlikely I'll be exactly 50 heads and 50 tails, but I'll probably be pretty close to 50%. So point estimates are likely close to the true value, but unlikely exact. So there's usually some kind of error involved in the estimate, just from random chance. So in addition to supplying a point estimate to a parameter, the next logical step would also be to provide a plausible range of values for that parameter. So that plausible range of values for the population parameter is called a confidence interval. So using only the point estimate is like fishing in a murky lake with a spear, and using a confidence interval is like fishing with a net. You can throw a spear where you think you saw the fish, but you'll probably miss. On the other hand, if we toss a net in the area, we have a good chance of catching the fish. So if we report only the point estimate, we'll probably not hit the exact population parameter. We're likely going to be off. On the other hand, if we report a range of plausible values, which we call a confidence interval, we have a good shot at capturing that parameter. So, as far as terminology goes, the point estimate is the most plausible value for a parameter of interest, so it makes sense we're going to build the confidence interval around the point estimate. And the margin of error is basically how wide you're going to set your net. It is a measure of the uncertainty associated from the point estimate, and is found by multiplying the standard error with the confidence coefficient. And we'll get to those in a moment.